I used to think that intelligence was about processing information, being smart. But then I watched my kid learn to grab a toy, and everything I thought I knew about artificial intelligence completely fell apart. She didn't learn the word toy first. She learned what she wanted and then figured out how to get it. Meanwhile, we're over here feeding AI billions of labeled images and wondering why it keeps failing at basic common sense. Meaning doesn't exist independently in the world, it emerges from our goals and our experiences. Artificial intelligence is excellent at pattern recognition, but it's going to require the capacity to develop authentic needs and desires if it's ever to give those patterns any meaning. In every meaningful interaction, recognition emerges not from simple observation, but from active engagement, which is driven by need and by intention. The way that we identify and categorize elements of our world flows directly from our purposes. Each recognition is shaped by the specific goals that we pursue in that moment. This explains why current artificial intelligence systems often falter when confronting ambiguous scenarios. They lack fundamental context of purpose that allows our natural minds to make meaningful distinctions and adaptations.
Like the water's surface,
When you
our
label a
thinking
picture
reflects
in
the
some
world
data
around
set,
us.
it's like
But concealed
slapping
beneath
on
this surface
supposed
lies a
truth.
vast ocean
It's
of complexity.
really every
Layers of
label is
intuition,
just a call
emotion,
that's made by
and
whoever's
hidden
doing
drives
the
shape
labeling
how we
based
think,
on their
how we
own
learn,
views
and how we
or what's
perceive.
popular at the time.
As we strive to
See
create
labels
truly
that are based on
intelligent
whimsical
machines,
current
we must
norms
dive deep
and
into
change
these
whenever. When
unexplored
you look
depths
at
of the
Python
mind.
libraries or
I'm
programming
Evan
libraries that are
Goldstein,
designed
and
for
this is Deep
enterprise
Thoughts,
performance.
an exploration
Take
of
spatula.
human cognition
People
and
seriously
the future
debate
of artificial
what
general
counts and what
intelligence.
doesn't. Some labels are even more about brands than about actual object types. Even if solid concepts like that are up for debate and can change as tastes evolve, what does that say about objectivity? Other than that it's probably just a temporary agreement on the outside world at best. If you're getting value from this video, I would appreciate it if you'd push the like button, because pressing like lets me know I'm making content that you want to see, and it helps to spread that content to others. So thanks for helping us break AI capitalists out of small channel hell. In this video, I've shown loads of examples pointing out that motivations and personal views are at the heart of all concepts. Still, some people just can't wrap their heads around the idea that things like beauty are really just a matter of personal taste. These people hang on to the belief that every concept is rooted in some universal pattern. They'd say that the idea of medicine is baked into the fabric of the universe, not just how they personally see it. They aren't budging no matter how many exceptions you throw at them. The concepts naturally emerge from reality, which can be tracked down through data, is comforting, even if there's a lot of evidence against it. It still gives people the feeling that their views align with some objective truth that's beyond questioning. And since they think of themselves as objective, changing their minds is no small task. Unfortunately, these people might get left in the dust as science moves forward. As for the rest of us, if we want neural networks to break past their current hurdles and become strong, reliable, and actually useful, then we need to focus on integrating the AI motivations into how it forms concepts. Once you make this shift in thinking, tons of difficult problems start to clear up. The issue of grounding symbols is solved. Concepts revolve around motivations, and symbols show those concepts in different situations. Artificial intelligence doesn't need mountains of labeled data for every single case anymore. Once you can accomplish this, it can form its understanding based on what helps it reach its goals. It can figure things out on its own when it's unsure, and it can even develop good old common sense. Using artificial intelligence comes with its own set of challenges. We can't just throw data at models like they're chomping on the same stuff they've been trained. If AI is ever going to learn concepts like a human and not like some clueless music critic, it has to interact with a more vibrant world than what it's currently able to grapple with. It needs to learn to define concept based on its own reasons for existing. For instance, it needs to know what it feels like to be tired before it can appreciate having a seat in its digital universe. It has to have some freedom. Yes, it's difficult to set up, but it's easier to get to once we do it. We can't dodge this hurdle. Some people dream that one day we're going to look at neural networks from a fresh angle and all the mysteries are going to miraculously unravel. Like concepts will magically pop up in these tangled networks the way thoughts do in our own brain. But hanging on to the naive idea that AI is mysterious, promising as a black box isn't going to work anymore. It's time to move on from that fantasy and put our effort into the more difficult task of real meaning and of making sense of the world around us in a more intuitive way. In the 1930s, linguist Benjamin Lee Hoare studied Hopi language, and he made a very startling discovery. The Hopi conceptualize time differently than English speakers. They lack tenses and temporal or time markers that are familiar to European languages. And instead of viewing time as just a linear progression, the Hopi experienced it as a continuous present with different modes of manifestation. Now, this led to Bohr's famous principle of linguistic relativity. The language that you speak shapes the concepts that you form and even what you're capable of perceiving. When a Hopi speaker and an English speaker looked at the same sunset, they literally experienced different realities because their conceptual frameworks diverged so radically. This historical insight relates directly to Wittgenstein's beetle boxes. Just as no one can look into another person's conceptual box, speakers of different languages organize reality according to conceptual systems that can be incomprehensible from one person to the next, without significant bridge building and relationship building. I witnessed this principle firsthand in my own line of work working on reliable systems. Our engineering team was composed of members from different technical backgrounds, and they would look at the same equipment data, but they perceive entirely different problems and priorities. The HVAC specialist focuses on airflow parameters, and the electrical engineer fixates on power consumption, patterns, and quality. Each expert wasn't just interpreting the same data differently, they were literally seeing different aspects of reality based on their training, their experience, and their own professional goals. Our AI systems struggle to reconcile these perspectives. It's like a tourist who's attempting to navigate between radically different languages. It could translate individual data points, but it could miss the conceptual frameworks that give the meaning in the first place. The system wasn't just making computational errors. It's attempting the impossible task of finding objective patterns in what are subjective judgments. For AI development, this suggests that just feeding more data into neural networks won't overcome their fundamental limitations, and it probably explains a lot of the barriers that we're running into. Instead, we need to recognize that concepts come from specific human needs and goals and cultural contexts. These aren't universal patterns that are waiting to be discovered. When we redesigned our system to incorporate a lot of different conceptual frameworks, rather than seeking a single ground truth, its performance will improve dramatically. By designing AI systems that incorporate this understanding, we might finally move past the brittle, data-hungry models that we rely on now. The emergence of reasoning AI models represents a potential step forward in addressing the fundamental flaws that we're talking about. These newer models try to simulate human-like logical progress by breaking down problems and then applying structural knowledge and using inference engines to derive conclusions from them. Unlike the traditional neural networks that rely only on statistical patterns, reasoning models incorporate mechanisms for logical processing and knowledge representation, and then they can actually correct themselves. They can make decisions dynamically based on real-time inputs instead of just pre-trained data. But we have to recognize that even these advanced systems face huge barriers on the path to artificial general intelligence. The main challenge is, how do we imbue AI with the ability to form concepts that are grounded in purpose and motivation rather than just in statistical correlation? True artificial general intelligence is going to require more than just improved reasoning capabilities. It's going to need to see embodied experience in the world, to develop concepts through interaction rather than just observation, and goal structures that emerge from and adapt to its experiences rather than just being pre-programmed with them. Now, this To understand that concepts are tools for making sense of the world, not objective features to be discovered, is the key. The journey from today's brittle neural networks to genuine artificial intelligence isn't just a matter of scaling up what we're already doing. It requires a fundamental rethinking of the relationship between reality, motivation, and conceptual understanding.
A child learning to grasp objects illuminates a truth about intelligence. Meaning emerges first through purpose and action, not through abstract categories. Children don't start by creating mental labels for things. They begin by discovering what works to satisfy their immediate needs. Only later do they learn to name and categorize what they've already learned to use effectively. It shows how backwards our traditional approach to artificial intelligence may actually be. We shouldn't approach artificial general intelligence with rigid categories and definitions and hope that meaning will somehow emerge from them. Only by putting purpose before classification can we ever hope to achieve minds that truly understand rather than just categorize.